we want what we need today, as soon as possible. And so because of all these changes that are occurring within the market, Autodesk decided to answer this with building a product innovation platform, right? Something to help organizations and our customers differentiate themselves and also innovate quicker with some of the new technologies in the market today. So at the very center of this is the Fusion platform. And what the Fusion platform is it's a design, make, and use platform. And so when we talk about design, make, and use, we want to make sure, one second.
Muted.
We just want to make sure that you have the tools in place to design quickly. And a lot of us in the CAD space today are used to these traditional tools like Inventor, SolidWorks, Creo, Pro Engineer, even AutoCAD. But what we wanted to do is we wanted to build a platform that would allow you to design and iterate and innovate much quicker. Then we wanted to tie in this make and use, right, all into one encompassing platform. So, CAM, for those of you out there, computer-aided manufacturing, being able to take a part that was designed in a CAD program and quickly generate tool paths. Today, that workflow it's there, right? There are CAM tools, but how does that interaction between those two different systems generally occur? Well, we're probably exporting out data from a CAD system, importing it into a CAM system, and then the inevitable change happens and we have to kind of start that process over. So what we wanted to do is tie this CAM into the design platform, and then finally we wanted to introduce use. And what we mean by that is this is bringing the product development process full circle. It's designing, conceptualizing an idea, making that product, and then being able to monitor usage and gather metrics from the usage of this product. So a lot of us have heard of like IoT, and that's exactly what we're relating to. So here, if I kind of step forward one more, we're looking to take this product innovation platform. I should kind of go back before I go to this generative stuff. This is where we're at today with the Fusion platform, right? We're this full encompassing product development platform, but what we're trying to do at Autodesk is expand into other areas, right? So in future development, right, in the design workspace, we're slaving night and day to try and figure out how generative design is going to work and start to shape how we conceptualize and create geometry on the screen, right? So for those of you who are not familiar with generative design, this is really looking at the real-world application of our product and specifying how it needs to act, right? We would apply a goal, and we would apply constraints within this product development platform and allow the computer and its infinite computing power to generate our shapes for us. A lot to come in the generative space within the Fusion platform. In the make space, right? I think we all know 3D printing has become a very popular means to prototyping, but we at Autodesk believe this will become a more, I'd say, sustainable production manufacturing method in the near future as metal printing, that technology starts to expand. I'm sure some of you have seen imagery of 3D printed metal parts now. We are working on the software side to ensure that we can collaborate and work with these machines to help you go from design directly into make and actually producing a physical product. And then, like I mentioned before, we're looking at different ways of how to introduce connected products within this platform. And about 2 years ago now, maybe it was a little less than that, Autodesk acquired an IoT tool called C-Control, and what that does is it allows us to integrate sensors into our products directly within this product development process so that we can monitor usage from our customers. So, imagine something like an elevator, right? Like an elevator company like ThyssenKrupp. They want to start understanding, how often the elevator is used in a particular building, how many people are getting in at certain times, right? They can start to understand this and even gather metrics as to when this thing needs to be serviced and then they can start providing their product as a service, right? Not just selling with a one flat rate up front. Here's the elevator you've purchased, boom, now you have it. It's like we can now start to offer services, and we actually know when these services are needed to keep our products maintained correctly. So this is our product innovation platform, kind of at a very holistic, high-level overview. Today we're going to be focusing on the 3D CAD aspect of the platform. And I say CAD, you'll hear me kind of use CAD and platform interchangeably today, because what you're going to see with Fusion 360 is it works differently than your traditional CAD tools. Like I mentioned, SolidWorks, Inventor, Creo. We're trying to take some of the small nuances that we've just been accustomed to over the years with those systems, and we're trying to eliminate them entirely. And I hope you'll see what I'm talking about. But kind of the biggest value propositions of the Fusion 360 portion of this product innovation platform is that it's integrated, connected, and accessible. And what we mean by that is this product was originally built from scratch about 7 years ago. That's when we started development on Fusion 360. And what we're trying to do is build a system that's integrated, right? We don't have to have all these different silos of content generation tools. We're trying to bring them all into one space. We're trying to keep people and personas within an organization connected. And what I mean by that is, industrial design group, how they communicate with the engineering and drafting group, and how those guys communicate downstream to the manufacturing group. Think of how that's done today in your organization. It's probably a little siloed. If the industrial design group's producing data, it's probably an import-export to the engineering tool of choice. Then it's an import-export to the manufacturing group and their tool of choice. So we're trying to keep people connected and allow people to communicate much quicker, and then accessible. So Fusion 360 is a hybrid cloud product, and it is accessible and on any device. And we'll take a look at some of that today. So for those of you out there with Macs and you've been waiting for a CAM or CAD system that's native to the Mac, the day has come. So Fusion 360 is exactly that. So I didn't want to spend too much time inside of this PowerPoint. So what I'd like to do now is we'll jump into Fusion and we'll take a look at what this tool actually is capable of. All right. So I'll just let that refresh real quick. This is Fusion 360. What you're seeing on the main pane here is kind of similar to a traditional CAD tool. I have a ribbon of commands at the top. I have an assembly tree, and at the very bottom I have my feature tree of how this thing is actually been put together and designed. In the center of the screen I have our Autodesk Ember printer, and most people don't know that Autodesk has a 3D printer, and we didn't start developing a 3D printer to get into the hardware space. We actually developed it to push this technology further into the future. This Autodesk Ember printer is completely open source. So if you're interested, all the files, CAD files, the detailed drawings for manufacturing, the code that runs the software for this machine, it's completely open source. And what we're hoping to gain out of this is to push this additive manufacturing technology quicker into the future. Actually, a recent story I heard, someone took this printer and through I don't know exactly what they did because I'm not a software programmer myself, but they took the software that's running this printer and they were able to manipulate the code so that this thing actually printed twice as fast as it was originally developed to print. So, for me, that's huge for 3D printing. I still feel like 3D printing obviously has tons of pros in terms of the pro-con scale, but one of the things that's always been kind of lacking in is speed. And I know that if I were to take a part and CNC it versus 3D print it, the CNC machine would probably win every time. So that was cool to hear. But let's take a little bit of a tour. I know you kind of started in this main pane. Something that may look a little unique is on the left-hand side of this page. This is what we call the data panel. And so as I mentioned before, this is a hybrid cloud product. What I mean by that is some of the computation is done locally on the machine, some of the computation is done on the cloud. One of those cloud services that's a part of this platform is data management. And so what I'm looking at here as a Fusion user is my data that's being stored in the cloud. And I've organized my data in terms of projects. So at the very top here, you'll see I'm in the Ember Printer project folder. And inside of this folder, I have two tabs. I have a data tab and I have a people tab. So under data, I can organize, via folders, putting specific CAD files, drawing files, non-CAD files into the system, and I can start to organize them. Below that, I have some 3D Fusion CAD files, and below that I have a Word document. So this system in the background that's managing data within Fusion can actually accept any file type, and it doesn't have to be it doesn't even have to be a Fusion CAD file type if you'd like to manage CAD data. We actually can put SolidWorks files in, we can put Creo files in, NX files. It doesn't matter what the CAD data type is. It understands CAD and the relationships associated to it. So here, obviously, I want to discuss, product development inside of this space. So I'm going to show Fusion data, but we can house other types of CAD data. To the right, I have my people folder, and these are all the folks that I've invited into my project to collaborate on this data with. Right. So any of these individuals here, who I should say don't all have to be Fusion users. They all have access to this data. And for folks that are in this folder and are collaborating with me on these, on this project or on this product, if they don't have Fusion, they can still be invited to this project, only they're going to access the data inside of what we call A360, which is a browser-based access point for our data. So here inside of Fusion, I'm in the data panel, but for folks who are maybe not Fusion users, they're going to access data inside of the browser. And we'll take a look at that in just a minute. So let's come down to this file that I actually have open in the screen, this Ember assembly. A couple of important details. I can see right now that it's in use by me. I can see the last version that was created and the date it was created upon. And if I kind of scroll down here, I have what we call versions. So this is our attempt, and I think it was a very good attempt, or I should say a successful attempt, to start making data management transparent. Before I came to Autodesk, I was working at SolidWorks, and I was a PDM specialist, which is just product data, right? Being able to manage product data files, basically. And in CAD, when you're using traditional systems, we have relationships between assemblies, drawings, and parts. Those can become very cumbersome. It's not like a fun activity as an engineer or a designer or anyone in manufacturing. No one really likes managing data, and so one of our biggest priorities in developing this platform was to make data management transparent and very easy. And so in here, what you're seeing is the design history of this file, and it's being tracked by versions. So I can go all the way back to the very beginning when this file was originally developed inside of Fusion. And notice over on the right-hand side, I can take a previous version at any time and I can promote it to become the latest. Now, why this would be beneficial, a little history about myself. After SolidWorks, before Autodesk, I started doing my own contract work. I was doing freelance engineering and design work, and the story goes like this. I sit down with the customer, I get their requirements and specifications for the product they're trying to develop. Right? These are like entrepreneurs, inventor types, businesses that are trying to come out with a new product. I take that information, I go and sit down, I design something, right? I come back to them and I say, hey, Mr. Customer, here's what I've been working on. How's this? With a chip on my shoulder. Oh, Dan, hey, this is great, but we want to change X, Y, and Z. Everything else looks good. Okay. That sounds great. So I go back, I make the necessary changes. At the time, I was using SolidWorks. So what I was doing is I was trying to do like pack and goes or even overwriting the stuff that I had previously done to make these changes they wanted to see. Then I would go back to the customer, and of course, every single time, Dan, you know what? This looks great, but we actually like how it was before. right? It's like we need to go back to how it was before. And with a traditional parametric tool, without a PDM system really put in place, it was hard to go back to what I had already done. So here, if I ever want to go back to version 10 and promote this to become the latest, boom, one-click workflow, and now this is the latest, and I still always have the history of everything I've done to date. Another benefit of having this history is I can open up a previous version of this file and compare it side by side of the latest version. So if you imagine, when a change occurs within a production environment, hey, we need to see what changed and why. It'd be very beneficial to open up the CAD files and see the actual geometry changes that have occurred between the two. So that's a little bit of data management. I don't want to get too deep into that. What I want to do, though, is talk a little bit about the access point for non-Fusion users, right? I want to collaborate with some of those folks I've invited to my project. They don't have Fusion, so what they're going to do is they're going to access this data via A360. So I'm going to open up my browser here. I'm going to just pull this on the screen. And what this is doing is this is my access point for my data inside of Chrome. Now, all you need is any sort of web browser and internet to access this data. And obviously, I myself am a Fusion user, so I can come in here and see just about everything, and I can open this design in Fusion because I have Fusion. But for folks who aren't Fusion users, they're going to see all of this information here. They're going to see related data to the file, renderings, and you'll see as we move through, we actually relate all data that we generate in Fusion into this one space. So all the renderings we create, all the CAM toolpaths that we're going to cut with, all the FEA analysis files, any animations that we build out, all of that information is tied into one central location, and this can be accessed on anything with an internet connection and a web browser. So all of this stuff here, I can actually access directly from like my iPad. I can be out in the field, and maybe I'm a project manager working with Dan, and Dan's the engineer. I can actually come in here on my iPad. I can click on this image of the file, and what it does is it loads a dynamic viewer inside of the browser. So I'm actually opening up this file, and I'm able to kind of spin this model around and review to date what's been done. So if we come in here, we take a look at what this file is looking like. For those of you who have used like SolidWorks, even Inventor or Creo, they generally have a CAD viewer product, but it requires a local install. And if you've ever worked with someone who's not tech savvy that needs to review stuff that you've been working on, it can be kind of cumbersome. Here, all they have to do is click on the link of the file. It opens up in this lightweight viewer. They have the ability to mark up, comment, they can measure, section, even explode the model. And I would say this explode tool works really well, right? I mean, and it's all here for the viewer. It's the person who's consuming the data. But again, as an engineer or a designer, I may be working with a project manager that has, information about what needs to be worked on next, right? He's managing the entire product or project. He may want to kind of quickly notify me of, hey, what are Dan's next steps in the process here? So if I come down here, I actually have the ability to comment on specific objects. So we're pretending right now that I'm the project manager, and I may say, hey Dan, actually what I can do is I can actually tag someone in my folder. I guess I can't tag myself, so I'll tag Jake. Can you add an arm cap to finish this design? And yes, I spelled it wrong, but I won't go back. But I can post this out, and what we see inside of this space is a dynamic commenting feed. So you imagine today the social media feeds that we all comment back and forth with one another. This comment I just made now will notify Dan via email that he has some work to do to this model. And the best part about this is that it's dynamic. If Dan's in Fusion, he actually gets a little pop-up notification in the bottom right-hand corner saying, hey, project manager ABC guy, he just commented on this file, something needs to be done. Another great thing in terms of collaboration within the Fusion platform here is the ability to share data externally. So we've been talking about folks that are collaborating inside of that project folder, but let's say a vendor needs a file from you, or a contractor needs a file from you or something, right? What do you typically do? You're probably taking your product, your CAD model, you're saving it out, or I should say you're translating it into some neutral file format to kind of conceal your IP and how you designed it, and then you're attaching it to an email and you're sending it off, right? Well, as soon as you do that, you have now basically broken the connection of what that external individual has and what you are continually working on. So what we're doing here is under this share icon, we turn on links, live links to files, and I now can just send this link to an individual outside of my organization. They're not going to have all the same abilities like markup and comment capabilities, but what they can do is they click on this link today or they click on it 30 days from today, they're always going to be taken to the latest version of this file, which is phenomenal, I think. Any changes that you make, next week, they click on it a week from then, it's like they're always going to be looking at the latest version of the file. So we don't have to worry about this back and forth. I'll send you this CAD file, you make some changes, you send it back to me. It's extremely nice to be able to collaborate with folks like this. You also then have the ability to allow viewers to download to their computer. So you're not doing that translation anymore. Maybe you're sending this out to someone to get a quote and they're going to laser cut a piece of sheet metal for you. You send them the file and in their browser they choose their download format, right? Maybe a prototyping lab, some guy wants an STL, this other vendor wants a step file. Each of them get to choose what file format they want, and all of the translation is done on the cloud, so you don't have to tie up your local machine when you're sending out data anymore. So A360, again, a good access point for folks both internally within the organization in terms of collaboration, and also a great tool to be accessed on the road, out in the field. We'll come back to this at the very end because I want to take a look at this file and some of the things that we've generated throughout the rest of the demonstration. So I'll minimize this for the time being. We'll close the data panel. The request or the comment I had received, hey Jake Bosman, can you add an arm cap to finish this design? That's the comment I just made in the web browser. So you'll notice here it's dynamic back and forth. As a Fusion user, I can be commenting directly within the application, and my field tech out in the field can be commenting on his iPad back to me in real time. So I know the work I need to do. I need to kind of generate an arm cap for the front end of this model right in here to kind of enclose this spherical component to keep it in place, right? That's my printer head. So I'm going to go ahead and just open up this file. This is a subassembly within that Ember printer. And what I want to do here is I want to talk a little bit about how we develop products inside of Fusion and how it's a little different than the traditional CAD system. So very first thing I want to point out, excuse me, is in the upper left-hand corner is this Workspace Manager. So right now we're in the modeling workspace. That's where we're going to start to generate geometry. The modeling workspace allows for many different modeling techniques. You're still going to have your parametric modeling capabilities like you would inside of SolidWorks or Inventor or Creo, but you're also going to start to expand into other areas like T-spline technology for generating very complex G2 surfaces. Right? You'll still have the same surfacing capabilities you would find inside of SolidWorks. We actually give you two different surfacing options, but we also have great direct editing and patching capabilities. So right below the model workspace, we have patch. If you've ever imported data from another system or someone has sent you a step file, an IGES file, a SolidWorks file, and you've opened it in your CAD system, sometimes there can be translation issues. That's just inevitable between CAD systems and the different vendors out there. It's inevitable that we're going to get a model and some seam or corner face is going to be ripped open. We have great patching capabilities in here, and we'll take a look at some of that as we go through the model. But all we have to do is click on the workspace to move into that realm to get the appropriate tools to generate content. So right below model and patch, we have rendering. This could be an entirely different persona that works in the render space. It could be someone from marketing, right? Instead of the marketing individual hassling the designer or engineer to produce renderings for their brochures, maybe they come in and they grab a file that they need, they move into the render workspace, and they start to produce the marketing material that they need. Below that, animation. A lot of folks, are like, well, animation's cool to like show how my product works in the real world, but we don't really need that for any reason. Let me ask you a question. Do you ever have to produce technical documentation using imagery and words on a document? Right? My biggest example here is an assembly procedure. Think of something like an IKEA, right? They send you a brochure with how to put the product together. Why not have that always be up to date with the most recent data that's been created inside of the model space? So we'll take a look at animation. We'll build something out so you can see how easy it is to build out an animation. Below that, simulation, right? This is generally I would say an analyst or an engineering persona's workspace. They're going to go in and start to analyze how this model will react in the real world when real loads are specified. The biggest benefit here is that we're able to kind of reduce the cost of physical prototyping. Now, by no means should we ever eliminate physical prototyping, but what simulation and FEA analysis allows us to do is cut back the number of physical prototype tests that we have to perform. Some of the biggest benefits of simulation, most people think, hey, it's just to make sure my product doesn't break. I think that's obviously the number one reason you would use FEA, but another big benefit is to optimize your design, right? Maybe you can use a different material that's cheaper, right? I go in and I realize, hey, I've over-designed this thing. This load that's going to be applied in the real world is actually not really doing much to my model in terms of stress. Maybe I can use a different material that's cheaper, right? So I think simulation in FEA is always a must. And then obviously the big one that a lot of customers are super excited about is that we've integrated CAM into this environment. So the actual make, right? The design and make, boom, here it is. I want to take and design something. I want to produce some marketing materials and some technical documentation. I've done some testing. Let's generate my CAM toolpaths and go start cutting metal, plastic, and actually make this thing in the real world. So you'll see, we'll walk through each of these. I know we don't have a lot of time, so I'm going to move pretty quick. Let's start by right in the assembly. I'm not going to care about starting a new file, right? I want to create a new part, but I don't want to start a new virtual component, and I'm using air quotes. I don't want to have to activate something. I'm just going to, I want to work as intuitively as I want to. And in this space here in the assembly, I would normally just want to start a new part, right? So I'm going to just create a sketch, and I'm going to project this opposing side, and then using kind of these I'd say right mouse button, quick mouse gestures, I'm just going to grab my sketch tools and I'm going to close off this profile for an extrusion that I'm going to make. I also can come down here and kind of close off this profile at this edge, but let's say for some reason I'm just having a difficult time snapping to this edge. No worries. I can just go past that boundary, and what Fusion will do is it'll actually recognize that profile for you. It understands this is a closed profile, this is a closed profile, and this is a closed profile. So what I'm going to do is I'm now going to extrude some solid material. And I'm going to use this tool called Press Pull, which you'll come to realize is really many different features built into one. And I'm going to just grab the profiles that I want to extrude out. And notice once I've grabbed my 2D sketch profile, my Press Pull command automatically said, hey, you want to make an extrude feature. So again, this is the small things, the small little details we're trying to improve in CAD geometry development and being able to quickly put ideas into CAD, or into 3D. Another thing I want to point out here before I actually pull this thing out to create my solid body, notice this. Right now my top level assembly is the active component. As soon as I pull this out, I'm affecting geometry right in front of it, so it assumes, hey, you probably want to cut away material from this ball component. So guess what? Fusion automatically activates this component, and if I say OK and accept this feature, that feature now resides in that component. I didn't have to think about it. Fusion understood what I was trying to do. Now, the funniest part about this is that I actually want to create a new body. So as soon as I do that, I'll choose my value of how far this will go out, and it reactivates my top level assembly. And when I say OK here, what it does is it builds out a bodies folder at my top level. And what I'm left with is this body inside of my model. So, you know, because I have some components already where I need them, and I'm building this thing in a top-down approach, right? Like at the assembly level, I'm going top-down. I'm building in the context of everything that it's going to be interacting with. I'm going to use some of those things it interacts with to design. So using S as a hotkey on my keyboard, I'm going to come into my model toolbox and I'm going to use a tool called Combine. And I'm going to take this body I just created and I'm going to cut it with this spherical component that's already in my model. So I choose my operation and look what it does. It shows me a preview of how it's going to cut material away where these two overlap. And when I say OK, I'm now left with my body number 6 and my body number 7. And I don't need body number 7, so I'll just quickly remove that. I'm going to turn off my ball component. A lot of you are probably like, well, that ball, if it's really cutting away material, those surfaces are theoretically touching, and in the real world, we need to have some tolerances. So I'm going to grab that same press pull command. Watch this dialog box. Press pull. I choose this surface. Hey, you probably want to create a feature called offset, and that is exactly right. I'm going to now grab this surface, and I'm going to offset this 1/4 millimeter to account for tolerances when this thing is actually put together in the real world. Same press pull command. I'm going to grab 2 edges this time instead, and boom. It wants to create a fillet feature. Now the best part about this is not that it just created a fillet. It's cool. A lot of times we can just highlight an edge and say create fillet. The coolest part about what I just did is I am creating a feature across 2 different components inside of my assembly at the exact same time. I say OK here. I just affected a body and a component. And if I look at my feature tree down here, notice it highlights the fillet and says this is in multiple components. So that right there is allowing me to just design faster. And again, these are all the small little nuances that we've tried to change to allow folks to quickly generate 3D geometry. So I'm going to come down, and instead of starting a new sketch at my assembly, I'm just going to grab my tool, and it already knows that I want to do it on this face. When you get really good with Fusion, you can start just drawing lines to the sketch tools that you need. I'm going to go ahead and throw my dimension on, and then using my press pull, I'm going to come in here and just kind of etch away some material on the side. And then again, press pull, let's grab these edges here, and we'll just do the same thing we did on the top. I'm going to open these up for a counterbore. Now, I talked a little earlier about patching. Notice what I did when I projected this edge of this arm base. Kind of when I extruded out, made this weird fillet when it kind of broke it apart into 3 surfaces, and that's due in fact to we had a fillet here and a concave and convex surface. All I need to do in Fusion is highlight those faces and hit delete, and it understands how to patch geometry back together. Now that was obviously a really easy example. It knew to come to a point on the corner, but you can take this into some pretty wild spaces and start to hit delete to remove extra data that's not necessary, and it's pretty darn good at understanding how the surfaces need to be patched up. So very lastly, to kind of speed up the sketching aspect, I'm going to take an existing sketch here and just bring these right here. Right, I want to bring these down into here, and I actually want to maybe go to a specific distance. So I'll say 2, and I'll just highlight this face on the opposing side, and now there's a parametric link between those. So again, we talked about different modeling techniques. Fusion allows us to blend all of these techniques together. You've seen a little bit of patching, a little bit of direct editing where I'm dragging stuff around. Parametrics, right? I projected the original component in here. If that were to change size, my arm cap on the end that I'm designing, that will also change size. So we have those different modeling techniques that we've covered, but let's talk a little bit about like advanced surfacing. So inside of your traditional CAD tool, how do you create a surface, right? There's probably quite a few different ways, but a parametric surface is generally going to be, hey, I'm going to create a sketch here on this plane, and then a couple inches away or whatever, I'm going to create another sketch on a different plane. I'm going to loft or sweep these 2 together, and then I'm going to manage the complexity of that surface with like guidelines or guide rails, depending on the system you're in and terminology. That is all in Fusion, but a lot of folks have already seen that or have used that before. What I want to introduce you to is what we call our freeform space. So inside of this modeling workspace, I can just come over to create form. What this does is it turns off all of my solid geometry, right? I'm about to create some complex surfaces. So you imagine I'm going into like a surfacing type of environment, and that actually shows up here that I've moved into the sculpt environment. And I can start with some generic shapes if I really want to, right? I could start with a cylinder that's been subdivided into multiple faces, and then I can start to push and pull to a specific degree to achieve the surface I'm trying to get. Now, what I want to do is use this utility called convert. I'm going to take this front face and I'm going to convert this into a surface. And this surface has been divided into a 4x4 segment. So you imagine this is one surface body, but it's being divided into faces. And what freeform or T-spline technology allows me to do is, you'll see me come to this tool. I'm going to edit my form. I can highlight faces, edges, and vertices, and when I do, it gives me this triad, and this triad allows me to rotate whatever my selection is. It allows me to move it along an XYZ plane, or scale it in the XYZ plane, or scale it in 3D. Right? An example of this is, let's just move this or translate it in one direction. And I can now pull this point out because that's what I had selected. And what it's trying to do is always maintain G2 continuity. It doesn't matter what direction you look, you can imagine this as a spline surface, right? It's always trying to maintain this G2. So I'm not going to do exactly that. What I want to do is I want to take this top edge, and maybe I'll highlight this bottom edge as well, and I want to just kind of wrap these guys back. And I want to go a specific distance with this. I want to go 6 with my top and bottom edges, and then I want to take this side here and I want to bring this back, but not too far. I don't want to go past my counter bore. I kind of want to come to right about here, and we'll call this 6.5. And then to kind of finish up on this side, I'm going to take this one back just a couple of millimeters. Right? We'll say 1.5. And so right now, doing that, I've just created a fairly complex surface that would have taken me a lot longer to do inside of the parametric tool with the traditional surfacing techniques. Now, granted, you could do this. You can absolutely do this inside of SOLIDWORKS, Creo, Inventor. It doesn't matter. All of them can generate a surface like this. But can you do it as quick? The other benefit of the freeform space is when changes occur. I used to use SOLIDWORKS for advanced surfacing, and whenever I needed to make a change, I would go back and do it, and I just knew my model was going to turn red. And for those of you that have used SOLIDWORKS before, you know exactly what I'm talking about. Another cool part about this freeform space is we can actually extrude directly from within this face. So I'm going to get this guy out of the way. I can hold down the Alt key with any of these translation tools, and I can actually pull out and extrude from my surface. And again, check it out. It's still maintaining that G2 continuity. Now, keep in mind with a surface tool, sometimes we don't want G2 continuity. I'm going to remove this back. I just want to demonstrate that. We have lots of different tools in this space. We can crease edges, right? So I like to bring that up because not everyone's like, well, that's cool, but like my car, right? Someone used some sort of surfacing techniques, and I have like real like aggressive edges in there. Well, a lot of surfaces are G2, not all of them can be, right? And so we have tools in here to help you generate the appropriate shapes inside of this surfacing environment. So let's say I'm finished with this surface. I say finished form, and what I'm left with now is a surface body that I created at my top level assembly, and I can now use this to cut away the unwanted material from my arm cap. So I'm going to hit S to access my my little toolbox of features, as well as a search tool that I can start to type, and I can find the feature I want. I want to split this body with this tool. And it's nice to be able to extend the splitting tool. If necessary, I can say OK. And what I'm left with now is this excess bodies, these bodies here that I don't need anymore, and I can just come down and remove those, and those are captured in the timeline down here. So if I ever need those bodies back, no big deal. Let's just revert back in our parametric tree, and there they are. So in a very short period of time, I was able to generate a very complex surface using some very easy to use surfacing tools inside of Fusion. So Next thing I want to talk about is a little bit 3D printing. How would you print this part right now? Well, you'd probably have to take that part, save it out as an an STL, which we can do, save as STL. Check this out. If I want to quickly prototype this design for form and fit, I can just come up to the 3D print button. I can highlight the component that I want to 3D print directly within Fusion. Gives me a quick preview of the print in terms of mesh. If I need to refine that, I can. And check this out. I have my print utility loaded into Fusion. I have a printer bot sitting right next to me. It runs on software called Kira. I'm going to send this directly to my Kira system without even having to generate an STL file. What that does, it opens up Kira, throws my file directly into the print bed within my printer application. And here, if I need to kind of understand breakdown of how this thing is actually going to print, I can do that directly from within the screen. And when I'm ready, I just hit print. No need to manage excess, STL files, across a network. You just push it right to your software, set it up, and print. So that's, I'd say, one of the best parts about this. Now, another thing about 3D printing, and I'll keep this pretty quick because we got to move fast, adding threads. I'm going to come to this hole and add a thread. I want this to be a 5mm hole, an M5 by 8, 6H right-hand thread. Now, if I say okay, it's going to create a cosmetic thread, which is just a graphic wrapped around that. But if I'm really 3D printing this and I want a thread to be there, I would have normally had to have done this, like actually generated the real 3D thread. Here we go. I'm going to hit modeled and say okay. I now have an accurate sized 3D thread within my model. And if I want to go print this thing on my printer now, I'll have the appropriate thread in there. So I love that part, just being able to apply threads very quickly. And under this make button, we have relationships with customers, or I shouldn't say customers, we have relationships with companies that can help you make things. That's why they're found under the make button. My favorite relationship we have in the Fusion community is with McMaster-Carr. I maybe want to insert a McMaster-Carr component into my model. No big deal. I'm going to come in here and just start typing. We have the embedded McMaster-Carr website directly within Fusion, and I can now come find my model. All right, let's kind of zoom down here to my M5 by, what was it, M5 by 8. I maybe want like a 30 millimeter long. I can just grab this CAD file within here, right? I'll change this to step and hit save. And guess what happens? It actually downloads and inserts this McMaster CAD file directly within my Fusion assembly. And so what you're finding now is it's at the very bottom of the screen. I can bring this up to be a little closer and say okay. Let's capture that position, and then let's talk a little bit about assembly. So here, unlike a lot of CAD systems, we don't remove degrees of freedom to bring components together. We enable motion. So I'm going to grab my joint command. I'm going to come down and grab an edge here and say, hey, this edge of that component, that's going to relate to this component at this point. So it brings these two together. I'm going to flip this guy around, and then I specify the motion type. So it's basically a two-click workflow to enable motion between components. I'll say OK here, and to kind of move this design further into the future, right? This is still a body in my assembly, and that body may have had a name like arm cap as we were designing it. When I'm ready, and this is the best part about Fusion, is it's so flexible. When I'm ready, I just right-click this body that I've been designing and say Create Component. And it immediately becomes a component in my assembly that's now, I can now apply motion to, and it's also now included on my bill of material in my drawings. So you'll notice I can now pull it apart, which is great. But again, I put this and designed this in the space that I wanted it to be. So instead of using a joint to bring this together, I'm going to use what we call an as-built joint. I'm just going to highlight this component and say, hey, these are rigid with one another, right? It was already exactly where I needed it to be. So I don't need to do anything else. If I wanted to, I could change what type of motions engaged between these two, but it's rigid. So the very last thing I want to do here is the ball. I'm going to take a look at this ball and do the same thing. I can just draw an upline to repeat my as-built joint, and this one is actually revolving around an axis. So I'll turn that there. A little preview occurs, but it's probably hard across the GoToMeeting. I'll say okay, and now boom, I have my assembly in place. I've put everything together in a very short period of time. Let's move a little bit forward. Let's go into appearances and apply some, excuse me, let's apply an appearance to this. I'm going to come in and grab this red aluminum, and then what I may do is just change my persona. Maybe I'm marketing and need to produce a rendering. So I'm going to come into this space now, and I have this model in place. And all I'm doing now, there's two benefits of this render space. One, very easy to use, drag and drop materials, lighting is easy to specify. But the two biggest benefits here is I have the ability to render in the cloud, and I have this render on save in my gallery down here. So I'm going to hit render in the cloud, and what you'll see happen here is it actually takes my design, all the lighting, all the appearances, it pushes that and calculates the rendering in the cloud, which is super beneficial in terms of time. Think of all the time you spend when you render today. At the end of the day, oh, I guess I'll do my rendering now. I'll let it run while I'm out the door or I'm at lunch, because it ties up your entire machine's resources. Inside of Fusion, we use the cloud to do rendering so that I can continue to work inside of Fusion. Now on the left-hand side of this gallery, we have render on save. These are images, past renderings that I've done that I always want to be up to date every time a design change occurs to the actual geometry of this model. So every time I've made a change and I hit save and I create a new version, all of these images are automatically re-rendered in the cloud. No human interaction. They can be accessed in the browser via A360. They're always up to date, which is super huge. So the rendering environment is very conducive to quickly generating renderings and ideas and having all of those stay up to date. So in terms of animation, animation is easy, right? I'm going to come to about 3 seconds here. I'm going to highlight a component and say transform, and I'm going to just pull this out. All I'm doing is saying this component is going to be here at 3 seconds. And when I say OK, you'll notice my timeline makes a transformation kind of icon down here. Then maybe at 3 seconds, right after it transforms, I want this thing to be hidden. And it then records that in the timeline. Same thing, I'm going to move up to 6 seconds here, and I'm going to say this component then transforms. So that gets pulled out. We're just exploding our model, right? This is our disassembly procedure. I may want this to occur a little quicker, so I'll move that down to 4 seconds of when it starts moving. And then at 6, I want it to hide, right? So what I just did is I just transformed and created an exploded view, and this is my assembly, right? All of this information that I'm doing here, this can all be recorded and viewed via the web. So let's just rename this, and we'll call this disassembly procedure. So without going into FEA, only because of time purposes today, I know I got 3 minutes, I want to jump into the CAM workspace. We've designed this thing in the context of what we've been working on. Let's turn off everything that we do not want to generate toolpaths for. So I'm going to come down here and turn off everything except for this arm cap, and we're going to take a look at how easy it is to generate toolpaths inside of Fusion. So very first thing, I'm going to set this up. I'm going to specify the operation, which is milling. I'm going to specify how my work coordinate system of my tool or my machine is going to basically be oriented according to my model. I have the ability to specify reference geometry like fixtures and clamps and things like that. Then I'm going to come to my stock and say, hey, I want this to be a specific size. So here's the size of my stock material. That looks pretty standard. I can probably go get a piece of stock material in those sizes. And then my post processor at the very end, after we've generated toolpaths, I can give it a name and add a comment. Once I've set up my model, I now just come between my 2 and 3 operation lists, and I start to specify how this machine is going to cut the stock. So very first thing, we're going to start with a facing operation. So I move from left to right, and for today's purposes, we're just going to specify the tool, and we're going to let it figure out the tool path on its own. So I'm going to filter for just my face mills here, and if I scroll down my library, I find my face mill. It gives me information about that face mill, including feeds and speeds that can be edited. Geometry, I would normally select what's going to be cut, but in this circumstance, I'm just going to let it face the entire top of the stock. And there we go. There's my tool path. Yellow is when it's coming down from the machine. Green is inserting into the cut. Blue is cutting. Green is exiting the cut, and yellow is the retract height. So again, same thing. I'm going to choose my 3D. I'm going to choose adaptive clearing, which is a technology that you'll only find in here, and it's for high-speed machining. It tries to maintain constant engagement with the material and the tool's diameter so that we're not putting excessive stresses on the model as it moves in and out of like pockets. So you'll see here it's generating a tool path. The algorithms are running within the CAM kernel, and it now has generated this very complex tool path to get this part cut. And if I want to, I can start to simulate this. So I'm going to turn on toolpath just as a tail, and I'm going to change the stock, material to ceramic so that it's easier to visualize inside of the GoToMeeting. And I'm going to just hit go, and I now can simulate my tool cutting my stock out to the size of the design that we created. We have information about the exact position of the tool and even higher end statistics of the total machining time to cut this part, along with the number of operations and tool changes. Now the biggest benefit here within the CAM and this like entire kind of platform is if I go back to the model space, let's just isolate this component for a quick second. And I'm going to use this press pull to quickly direct edit this model. Right? I don't really care what I do here because I just want to demonstrate that if I come back into the CAM environment, it understands a change has occurred within the model, and at this point all I need to do is just regenerate tool paths. Now if new features were added, obviously new operations might be required, but the best part about this is that it's connected. There's no more starting over as a manufacturing engineer in regenerating the tool paths. So I'll go through and speed this up so you can see the final cut. But it's basically taken away material on this left-hand side due to the design change. So this is the connected environment, right? The communication that occurs between design, engineering, and manufacturing. This is what we're trying to answer with Fusion 360. So I want to thank everyone who joined the webinar today. I always have a great time on these. I love Fusion 360. I wish I would have had this tool when I was doing my consulting work. It would have made my life so much easier. But again, thank you all for joining today, and have a great rest of your day. Thanks.